Problem 43 is a new example that is very similar to the rabbit and the cat problem. Just a different story, but still the same idea. So in this problem we have two high schools, Post Falls High School and Richmond High School. Post Falls currently has a student population of 1,160 and is growing by 22 students each year. Richmond has a current population of 1,900, but they are losing 15 students each year. So the question and the goal is, how long will it take for both high schools to have the same number of students, and how many students will that be when it happens? So first things first, we want to define variables. We are going to let x stand for the time and number of years, and we want to let y equal the student population in students. So step one, and again, we could make tables for this and we can graph this, but notice the size of the numbers. The graphing and the tables could be a little bit on the painful side, so algebraically is where we want to head with this. So remember that since the growth is steady, these are in y equals mx plus b format. Remember where m is the growth and b is the starting amount. So Post Falls High School is y equals m would be 22, and b would be 1160. So the way this reads is we start out with 1,160 students, and every year we need to add another group of 22 students. Richmond, this one's different. The starting amount here is 1,900. But added to that is negative 15x because the growth is negative, they're shrinking. So, again, y, and I'm going to put those subscripts in again, which I hope is not going to confuse this too much. This letter y stands for the student population of Post Falls. So if I put a little p next to it, it just means the student population of Post Falls. It's a little bit of a name tag. Over here, I'm going to put a little r next to this one for the population of Richmond. So I want to know when Post Falls student population is going to equal Richmond's student population. Well, again, what does stand for Post Falls student population? This y. Y of p stands for the student population of Post Falls. Over here, y of r stands for the student population of Richmond. What else stands for the student population of Post Falls? This is the math calculation that helps me figure out what that y is. So in its place, I'm going to write 22x plus 1160. So this is the math problem that figures out Post Falls population, and Richmond's math problem to figure out the population is negative 15x plus 1900. So to solve this equation here is going to give us the amount of time that's going to pass. Remember, x stands for the amount of time. So changing subtraction into adding a negative, don't need to do that. Combining like terms, don't need to do that. So now we're going to get the variable all to one side by creating a zero pair. So I'm going to add 15x here, which means I have to add 15x there. That's 37x plus 1160 equals 1900. Next, to get x by itself, I'm going to subtract the 1160. So 37x equals, I believe, 740 students. And then with all these 37x's, I want to split them up into 37 groups, so I divide both sides by 37. I'm going to need to go to my calculator for that one. So 740 divided by 37 equals 20. So in 20 years has to pass, and Post Falls and Richmond's population will be the same. But what will it be? That's our next problem to figure out. So I'm going to grab either one of these equations, and I'm going to plug 20 in for x. So up here, y equals 22 times 20 plus 1160. And again, I'm going to go back to my calculator. 22 times 20 is 440 plus 1160. That ends up being 1,600 students. Now, to be safe, that says what Post Falls will have. If I plug 20 right here and I also get 1,600, then that really makes me feel better that I did the problem right. So negative 15 times 20 plus 1,900. Negative 15 times 20 is negative 300. 1,900 plus negative 300 is 1,600. So that is added proof that we did this right. So final answer, after 20 years, both schools will have 1,600 students. And that is problem 43.